Hello, everyone. Thanks for coming out December 7th. Really exciting today. We got a very cool presentation, a really cool speaker coming with us. We have Stephen Fines, who has been working in the MLOps space for as long as maybe there has been an MLOps space. It's really exciting. He has an enormous amount of experience building really robust machine learning systems and machine learning stacks and working with different scales of companies to bring them from kind of ideation all the way through incredible execution. He's going to teach us a lot about the reasons behind MLOps, the motivation for MLOps, and hopefully we can all walk away with some really cool new knowledge. Stephen, thanks for coming on.
Thanks, Ben. So I want to go ahead and get started, but before I get started, I want to kind of highlight who this is going to be mostly focused at. I think it's going to be helpful for everybody who's working in the MLOps space, but a lot of this is focused at sort of the senior engineer, software architect, manager who is trying to decide whether they want to do this in their organization and decide if they need to do this in their organization and how to approach it. There's not going to be a ton of deeply technical things. There have been many other interesting presentations on the MLOps community covering things at a more deep technical level. And if there's demand, obviously I can do that. But I really want to talk about the thing I don't see a lot, which is why are we doing this? Because it seems like a lot. And want to move for that, and what's the motivation there and how this stands aside from other already entrenched IT disciplines. And so that's why we're motivating to MLOps. And I've broken this talk into kind of four main sections. One is, what does a machine learning production environment look like without some sort of unifying concept? What do you get, particularly as you scale beyond one or two basic models in production? And what does that mean in terms of level of effort and the headache that comes with managing complex systems in production? So with that, let's talk about, let's kind of get started here. So machine learning in the wild, and really this is not just machine learning. This is any sort of complex analytic system. So it's also applicable to non-machine learning systems like just standard statistical learning, is that without some sort of unifying idea, it becomes an operational and compliance headache from the production side. And the other caveat here is I'm going to be focusing a lot from the production side and very little on the how to train a model. There's tons and tons of resources for how to do a model training effectively. So we're going to kind of focus there. What kind of headaches do you have I seen in the past? We see things in the compliance realm. And when you have, say, more than 3 or 4 models and you need to monitor their compliance, getting it implemented uniformly, that compliance monitoring implemented uniformly, is a challenge because different teams are going to wind up supporting those models and their interpretation of compliance guidelines, if they even looked at them, may not be uniform or adequate. The other things are, are you legally allowed to use the data in that model? So do you have a framework for determining whether you can use that data? Because there are things like digital redlining and or contractual agreements around data sources that will determine whether you can and can't use that data set. And then you have some other guidelines that are around, depending on the industry, around data handling and automated decision making. So not only do you have regulation about what data are you allowed to put into that model, but you also have regulation around outcomes. And so this is a hard problem to solve once you go above a very small scale, because you have to continually monitor it, and it starts to eat up staffing just to do this. You're not even to implement new models, not to support them, but just to ensure your compliance is good. And it tends to eat up senior staff time more than anything else because they wind up being the people tagged for managing compliance. you also have, you have guidance around this from both the Federal Trade Commission um, and various other regulatory bodies in the United States, and then also international regulations, all right, like GDPR, can impact this because at some point the model itself becomes PI, which personally identifiable, and that then might fall into regulations around dealing with PI or NPPI and so forth. Um, the next headache is like just knowing what's there. If anybody who's worked in a line of business um, side will tell you that knowing what version is in production in a complex environment is often extremely difficult. And then with modeling, when you're starting adding an ML model, which has a pipeline involving complex steps like data prep, you've got your data prep and your data enrichment and your acquisition and then your training and prediction. Knowing for those components which version is in production can be very critical. Especially if you have, again, compliance responsibilities to answer customer complaints about the predictive outcomes of your model. You might have to, provide data on outcomes from a specific version of the specific model. And that becomes tricky. And then, do you know if it's actually in production? Which is oftentimes a good question. Like, am I actually in production, or did I kind of stop? And is anything hitting this? Did I put it in a production environment, but it's not actually being used? And that's sort of a tricky question. Ben, it looks like you have a question.
Yeah, we have actually our first question. Do you have some examples from your experience of the most time consuming compliance regulations, or if your experience has shown that they are different per industry? Can you talk maybe a little bit more about that?
They're definitely different per industry. The most onerous requirements I've had to deal with so far actually are from the credit industry, dealing around NPPI and how you access that data. Second is going to come from healthcare, like HIPAA. Um, and credit is there because there's a lot of regulation that's been existing since the 90s around automated decision making. And so there's a long history of statistical models being used and being deemed discriminatory. And so the credit industry has gotten a lot more substantial regulation. Um, Healthcare outcomes is mostly around private data handling because of the sensitive nature of personal health data. I anticipate seeing more regulation around data handling, California privacy laws, um, GDPR, EU privacy laws coming around, and they're going to start hitting many other industries once regulators determine a formula that works. And that's really what's going to drive that going forward. It's not going to be. Um, I'm hoping that they don't jump into it. That the rulemaking process, at least especially in the United States, that they don't jump into it with a ban hammer. They don't hit it and say, no, you can't do this at all, but instead take a more measured approach um, to doing that. But I can't really, I can't predict the winds of politics. And so from a regulatory, decision making, if you work in, say, logistics and you're determining using, simulated annealing to determine optimal route to solve the traveling salesperson problem because you need to ship a bunch of stuff, probably going to be less there than if, say, you're determining which class of people to use in a medical trial. That's part of experimental design. So, as with everything, it's going to depend on industry and nation, and state in the United States, state or province, depending on how your actual nation is set up.
Cool. Thanks.
So, the first one, kind of back to where we were. What version of the model made the predictions? What is it actually in production? Like, is anybody hitting the results? And this is important because if you have a model in production that's getting no use, the question then becomes, should you leave it in production or should you sunset it? Or why is it not seeing any use? Is it just because somebody forgot to route traffic to it? And these are things that fall in the MLOps space because you need to know um, whether it's useful or not. And that's can be very difficult if you get, um, one model, maybe not, 5 models, maybe, 10 models, probably, more than that, definitely. Keeping track of this becomes a time consuming process and it's very difficult to track versions. Um, and is the model still predicting accurately enough? And this is model surveillance. Um, this can be hit or miss depending on the experience level of the teams in the regulatory environment. Um, when do you retrain? And some of that's a modeling decision, but some of that's going to be based off of real world performance. Looking at this and going, oh, hey, um, model B over here all of a sudden went from 90% accuracy to 75% accuracy. What do we do? And you need to know that because if your model is driving revenue, then you see a sudden revenue fall off, you're probably going to want to know why. Somebody's going to ask you the question. And then if it's you can't, you didn't know that your model accuracy was dropping severely, then somebody's going to ask you why you didn't know. Um, and that becomes it's a difficult challenge without some sort of unifying framework to answer that question, unless you want to dedicate a large number of people just to monitoring model outputs. And in this case, a large number can be 3. People are expensive, so it can be what large number of people for an organization is not necessarily 20. And then you have your operational concerns. Bespoke pipelines. So when you get above 2 or 3, and each pipeline is completely custom. Team A did everything in Python with pandas, and they manually move data back and forth between various steps of the process. There's no ETL pipeline. And then Team B did something in Julia. Um, it becomes very difficult to maintain each of those processes. Um, One, because your operational staff, if you're in an environment where you build a model and you build a product, and then you hand it off to an operational team, you're not actually actively involved in the running of the product in production. Um, Training people to deal with these differences eats up a lot of time, and it's a distraction, and B, it just makes it hard to onboard that model into production, into sort of a production environment. Um, and then resourcing and support for the model just because modeling, machine learning, when put in production, actually crosses a great many different IT domains. And depending on your organization, that can be a deal breaker. Um, and so having something that's a little bit more unified where you can say, look, this is the operational domain this lives in. And these are the people who are going to manage that operational domain. And here's their expertise can make it easier organizationally to work with other parts of, say, an IT organization, such as a DevOps team or a on call or operations center, software operations center team. So they have a more it'd be more challenging if you say, look, well, we're going to take this discipline, machine learning, and there's going to be little tiny groups of machine learning in 18 different business units. Uh, your operations side of your IT organization might rightly go, no, no, we're not going to do that. And then it becomes a fight to grow and to add more machine learning stuff into a system. And these are kind of like the high level. What do you see? I mean, when you start getting down into operational concerns along the lines of, did my data get there? You also need some sort of unifying way to manage this, and you need some sort of unified um, conceptual approach to when you're developing things for how you're going to structure this. A lot of machine learning, and if you talk to Google's paper on systems to support machine learning, they say that it's modeling is 5% of the actual effort that goes into a machine learning product, and the remaining 95 is everything else around it. Um, my experience has shown it's more like 90-10. Um, but it is still a significant burden. There's, to get anything like the model is not enough. There's a significant burden to everything else. Not doing that in some sort of unified approach becomes problematic. That you'll spend a lot of time and effort just managing these, and getting new models into production becomes exponentially harder because you just don't have the people to do it because they're too busy managing the existing pipelines. Um, so is MLOps the hero of this story? Um, yes and no. Yes, in the sense of, from a working definition of MLOps, which is the definition that we're kind of work with here. Um, I think this definition is probably going to start a holy war, um, because I tend to say, look, MLOps is just a conceptual framework. How you implement MLOps, what tool you use to implement MLOps, is going to vary just dramatically depending upon your requirements, your organization, and your budget. Do you have just one model in production? Well, then maybe, having just a structured approach for, look, this is how we're going to do everything, and this is what the pipeline looks like. Maybe that's sufficient, especially if that's going to be the only model you ever do. Maybe that's sufficient. Maybe you don't need to go out and buy some expensive MLOps framework or something along those lines to get moving forward. Um, but if you have 20 or 50 or 200, then you probably are going to need some sort of framework, and you're probably going to want a vendor to support that framework. You probably won't want to write one that's bespoke. And, you're probably going to, look at how to adopt that effectively. So fundamentally, MLOps is just a conceptual framework for developing processes and tooling, to support how you get stuff into production and whatever production means. When you take it from this viewpoint, it allows you to kind of focus on the areas that you say, this is what we really need. This is where my organization needs help. Because in the end, when we look at any sort of practitioner approach to this, we have to recognize that models, and any IT solution really, models though especially, are viewed in one of two lights. They're either revenue producing, so they're products, or they're cost reducing, so they're internal tools for line of business for managing costs. You've got to be in one of those two buckets. If you can't fit cleanly in one of those two buckets, then life gets a lot harder for investing in it, and it's a much harder sell. In general, revenue products are easier to sell than cost reduction products to executives. It's been my experience, anyways. They like it when you make more money. It's a lot harder to go, I want to invest, 100,000 in something that's gonna save me 250. Usually it's like, well, I'll invest 100,000 in something that's gonna make me 250,000. That's easier to sell. But if I invest 100,000, I kind of may want to save 500,000. So your threshold becomes more challenging. And when you do that, then spending a lot of money on a framework when you don't have a huge number or on a tool becomes challenging. And that would it would say that a lot of places that probably need MLOps the most couldn't actually afford it. Um, because the perception there is that, well, I only need MLOps when I'm an enterprise. And in reality, you need MLOps more for the number of like the size of your organization doesn't matter. That's really more the number of models you have in production is what drives your need for an MLOps framework. Um, so if you are a two-person company with 50 models in production, you probably need an MLOps framework, of some sort. Now, is that a bespoke framework? Is that a custom framework that um, you've built yourself, or that's the bespoke framework, or is it a framework that you've gone out and purchased? Are you using Vertex AI, or are you using some other um, MLOps framework to do this? Um, that then that's an organizational judgment. Um, there was a presentation done on MLOps community a while ago called it was MLOps at a realistic scale, or machine learning at realistic scale, which is covers kind of a good framework for what you can do for some MLOps for a lot lower budget than, say, something super, super expensive. Just remembering that it's often a trade-off when you don't use a product versus when you do. And so from an architectural viewpoint, this is how I look at MLOps. Like, what's the framework and the processes I can use to support operationally running machine learning in production, and creating new products. The other objection I run into a lot is, isn't this just DevOps? Um, and they're cousins but not clones. They share some parts of the domain. But there are some things where I wouldn't want an MLOps organization to be responsible for. Infrastructure management. Um, if people who are my MLOps team is working on defining the networks in a cloud, they're probably not working on the right thing. They should, the CI or the DevOps team or cloud ops team, whatever you choose to call them, should be able to manage that. And you really, that should be a conversation between the two with a specification involved. Smaller companies where one person maybe wears both hats being the exception. Line of business app support. The skills your modelers and ML engineering teams have are not always best structured for line of business support. I know personally, I find supporting line of business applications tedious. It's putting data in a database and taking it out. And I think a lot of people go into machine learning have a very similar feeling towards it. And so they're often not the best people to have doing line of business support. They may be engineering skilled to do it, but it certainly isn't the exciting thing for a lot of people in the ML space. And then there are some areas where I put it in DevOps where maybe it's a gray area, your CI/CD. I would say supporting the infrastructure for CI/CD is strongly DevOps. Developing your CI/CD for any particular project should be in whatever team did it, whether it's an MLOps team or a ML engineering or just a line of business team. Probably don't want your engineers managing IAM in identity and access. So those are kind of their difference, where you probably don't want your DevOps people managing your model training pipelines. You probably don't want them managing your model surveillance. I mean, they might be there to say, hey, it's up and running, but do they really want to say, do you necessarily want them going, okay, well, my accuracy has dropped from 95% to 94.6%. Is this an issue? They're probably not the right people for that. Population stability index has shifted. Is that the right thing to do? And MLOps should be working with model development. And this is one of those, you could say MLOps/ML engineering/modeling, whatever you want to call model development part of the function for MLOps. But they're definitely not clones. It's not like you can say, well, I've got a DevOps team, I don't need an MLOps team. That would be in the end, what you would wind up with is a DevOps team with a small subset of people who really know MLOps. So you'd wind up with an unofficial MLOps team. If you have your models being developed in business units rather than in, say, an IT organization or a specialized modeling organization, you're going to wind up with a bunch of small MLOps teams. Because other people in the business units who are going to know how to do this. And whether you wind up formally defining a function or not, you're going to have an MLOps team. Where it sits, and if that's really what you want, is, that's going to be a question for the organization. My experience has been that a lot of scattered teams do not make for good operational, lower operational cost. Generally, Conway's law comes into effect, and the things that people are going to do when they're not part of sort of a more unified approach are going to tie into what their organizational structure says they're going to do. So certain things may not get done. Like they may not even talk to compliance because compliance is not in their organization. They may not even talk to your DevOps team and may build a model, and then they may just be like, "Oh, well, why can't I get this in production?" And then your ops and support teams go, "You can't put that in production. That violates so many rules that you just can't do that," and it causes a lot of organizational headaches. Obviously, in smaller companies where you don't have all of these teams, this doesn't work quite the same. You don't have maybe a compliance team, and you don't have maybe a dedicated support team. Um, and then you may have one person wearing all of these hats, and that person is going to be very busy. And your process of going forward may not move at the speed you want it to. Um, do you need to do this? Um, Kind of answered that a little bit already, which is to say, if you've got any MLOps in productions, you're doing something. It's an MLOps function of some sort. You may not formally call it that. Um, if you formalize it with a process, and even if it's a very generous process, I would say loose process, but a very generous process where there are a lot of options, there's not a lot of constraint. Um, but just having something written down that says, "Hey, this is how we move models into production," and then having people follow it, um, it will make it easier for you to develop and deliver products faster. They should be cheaper. Um, we'll talk about ways to work on the cheaper part here later. Um, but you're going to be there if you're doing anything. Um, it's just a matter of whether you want the formalization or not. I recommend that if you're more than a couple of models in production, that you do formalize it. You will find it your organization, and you will find it moves things forward faster and gets you better results. But formalizing these things sometimes is very, very hard. Depends on again, organizational friction. So pause here for a second. Ben, are there any questions that need to be answered before I move on?
No, I think we're good for now.
Okay. Looking at time. All right. So kind of what are the process framework components that you need to think about when you're deciding what's the process framework you're gonna do? Um, and we have the things, before you begin, what you're probably always need. Maybe you can scale with these, maybe you're fully mature with these. Um, so before you from prerequisites, really to do this, you need some sort of revision control system. And it needs to be MLOps friendly. Um, ClearCase, or what is it, ClearQuest, the old IBM RCS, probably not going to be a winner for you. I mean, maybe you can make it work, but most of your tools won't integrate with it. And you need some CI/CD implementation. It may not be super mature where you've got everything in a pipeline but you probably need something that can check your repository and build it on the regular. Ideally, it will run some training and validation testing so you know whether that commit was good, and so you can move forward. That's sort of like the bare bones. This is what you should have. CI/CD is probably maybe less critical. I would argue that it's not, that you should have it done first um, before you try to go into MLOps. And then that way, all of the MLOps tooling that already kind of ties in with this becomes easier. Um, you're not trying to kill two complex birds with one relatively um, big project. And um, that's kind of where those prerequisites come from. So kind of the foundational components, these are the things that you probably have. You need to do, you're going to develop on your own anyways, even if you don't do a formal MLOps framework. Like, you're going to have a pipeline that pulls your data in, prepares it for your model, and then runs the model, and then outputs predictions in some way. What that looks like depends on the model you might have, but you're probably going to want an engine that it can execute on. And so is this a custom, set of set of bash scripts that run this? They're just uniform? I would say probably not. You can probably get away with that for a couple small ones. Is this TFX or KFP or any number of commercial pipeline, ML pipeline execution engines? Maybe. I mean, they're complex. It's not a bad place to start if you have the appetite for the complexity and the models, and the time and the model requirements for those frameworks. But it doesn't have to be that. It could be Airflow. I mean, it could be tools like Airflow with a DAG, where the Airflow steps trigger your data prep, and then you run a batch prediction that way out of a Docker container. Um, that's a pipeline execution engine. Um, Even though it's more for Airflow for coordinating complex workflows, but I mean it's a simple workflow, so it's maybe this is maybe that's fine. Um, you need a delivery platform. You got to get your predictions somewhere. Whether that is you're doing this with Torch Serve or TensorFlow serving, and you're serving this from a web service and getting a transactional result, or whether you are dumping the output in a file of some type in a cloud storage bucket or on a file share on a network. I mean, that's a delivery platform. Um, so you need one of those. You need to decide what it's going to be and make it work. Now, you're probably going to wind up with both. You'll probably wind up with some sort of transactional delivery platform and some sort of batch delivery platform where you can do large files and large predictions. You need your machine learning and modeling tool of choice. Um, this one we'll talk later about standardization. This is one of the areas where standardization and tool of your choice often are seen as diametrically opposed. And they really aren't. Um, but we'll talk about that when I start talking about standards. And you need some data exploration tools to help you build models, and ideally they're built in with this sort of delivery platform, and you can look at not only raw input data, but you can also look at your exhaust, so you can understand what your model is doing and maybe build new products from that exhaust. But that's the bare minimum, right? That's like what you need to do any model at all. You need those things. So that is the absolutely bare minimum. Um, when you can talk about, how are we going to scale this process? This is where you've got maybe, 5 or 10 models going into production. Some of them depend on the outputs from others. Some of them have complex timing requirements because they pull in data from 40 distinct sources, and all those sources are updated at different times. Um, when you start getting into that place, you start needing something that's not just a model pipeline engine, but you need some sort of workflow engine that can coordinate and deal with time synchronization. And by that, I mean knowing of your 40 data sources that these 5 are updated on Wednesdays, and then the other 2 are updated every hour. And how do we latch that together so we can get a coherent set of data sources to drive predictions? And then how do we trigger model B, which model A depends on, based on all that information? Um, this is where the rubber really meets the road. This is where you start seeing the difference between um, ETL and a more complex MLOps environment. Um, the ETL approach to this would be you run each one individually. Each one outputs a file or some sort of result, and then when that's done, somebody manually triggers, or you wait 5 hours, and then the other job, which is scheduled via cron, kicks off and picks it up. Um, and again, maybe that's adequate for you, but if you're trying to accelerate your velocity in an MLOps environment, or in a fast pace many model ML environment, you're probably not going to want to do cron jobs. A, they don't necessarily deal well with um, exceptional events, and B, that may take too long. You may need those results faster, and so you may need to actually have either an event sourcing model or something that triggers these jobs when something else is done. You're probably going to want some form of automated model valuation or validation, pardon me, where you're looking at a model going, is this model continuing to perform well? That way, you're not necessarily looking at it all the time. You can be more of a man on the loop versus a man in the loop approach, um, where you're basically watching and supervising as the system does its thing. You're not actively involved in the execution of the system as much, and that's a man on the loop is sort of, I hesitate to say the holy grail of ML ops, but it is very important, um, because you're going to be responsible for multiple models, and you won't be able to spend too much time on any one of them, unless that one model you're working on makes just so much money that it justifies having an exclusive team. Um, you probably want a data catalog. You at least need to know your data lineage, and what data you have and where you're producing it, um, and ideally where its inputs are. Um, this and a feature store often get conflated. Um, you'll notice a feature store is not in this particular step for this particular approach. And it's not that I have anything against feature stores, it's just that I think they have a limited utility for most line of businesses or most businesses. Um, we'll talk about that later, maybe. And then you need some form of model surveillance. And this is, again, this is that looking at the predictions, looking at the outcomes, looking at the predictions, and going, are these where we think they should be? And this is different than model validation, um, in that model surveillance may have differing approaches to what you're looking at versus your value. You might be looking at different metrics. Um, the model validation may be just looking at hit rate and accuracy. It's like, are my hit rate and accuracy the same? Am I predicting, and is my prediction staying this accurate? Where model surveillance may actually be looking over the longer term, looking for things like hidden discrimination or things like that. So you know that, hey, my training set is starting to train in behaviors that are possibly out of compliance, or um, it's passing validation. What you don't want to have is something that's passing validation until it doesn't. Where a model surveillance may tell you that you're starting to trend downward long before your actual model validation um, logic or guards trigger. Um, and that saves a lot of time. It also saves you a lot of regulatory headache if you have regulatory um, parts of this. And then it also produces good exhaust data that you maybe can use for either preventive maintenance and so forth. And when you're fully mature, or you feel like you're fully mature, um, maybe a feature store. And the reason why it's over here instead of with data catalog, is that from my viewpoint, and this is an opinion that I have from some experience, is that a feature store is useful when you have a lot of modeling teams. They're all producing features, and then you have some other team trying to take those feature and make products out of it. Um, versus a modeling team where your modeling team is producing a product, where your model is producing a product. And this is one of the difference between where the data you produce is the product for your internal modeling team, and then the actual data set that's produced is the product coming out of your company. And maybe that's an aggregation of many different models. Um, that sort of work probably needs a feature store. Um, tracking where each of these features came from, what their lineage is, in that sort of a working environment is much more critical because when you need to answer to a data error versus an application, you're going to need to go back and say, okay, well, where did this data error originate? If you're dealing with a customer complaint, and try and resolve that issue. And a feature store can make that more useful. It can make that more possible. Some sort of lineage tracking, either separately or through your feature store, that says this model produced this data on this date, can help you track things a lot easier. And you're doing this because you're no longer just sitting there um, waiting on one model to finish. You've got a lot of models now, and you need to, have something that looks at these things individually. Um, and then the final thing here is kind of getting there. Like, how are you going to get here? This particular part of this is focused more on I have something. How am I going to get there? There are mostly it applies to people who are just adopting MLOps as well. Some steps maybe you don't need. And again, if there's demand, we can a talk can be had about how do you just start off with MLOps, not at the this is what technology you choose, but more of a how do I plan a project around MLOps? Um, so basically, it's the first steps are establish and developing modeling and establish development and modeling standards. You need to have some form of standards for any sort of unified ops to work. You need to automate the standard, enforcement, and then you need to train to that standard. So anybody who comes in needs to be trained to that standard, and that's what's over here. Um, because cut and paste. And moving model execution to pipelines. This is where if you have existing models that are not in any sort of unified pipeline, um, the approach I have is in the Microsoft Azure Cloud Patterns library called the Strangler approach, um, which basically what you want to do is you want to take a model that you're going to move to an MLOps environment. You want to containerize the model itself, and then things that are producing data for the model prior to model execution. That's the support stuff you move first. You don't try and mess with the model. Um, you don't mess with the model training. You just want to move the support framework into this MLOps framework that you're going to use. And you can leave the model as it stands, the existing model that's running in production, in a container somewhere or some other form of isolation. So you're not touching it. So you have it's lower risk, lower potential impact to your business, and a higher chance of success, both with getting people to agree to move this to an MLOps pipeline, because then you'll say, look, I'm not going to be actually touching the model. I'm going to be working on the support stuff around it. And a lot of times, especially if you have a separate modeling organization, the modelers are more comfortable with that. If, on the other hand, you can get away with saying, no, we're going to move everything to this new framework, um, more power to you. I'm jealous. And then you want to integrate it with your data catalog. You need to know what your model's taking in, and you need to know what it's putting out, and that should all be kind of tracked in your data catalog. What are its outputs, and what are its inputs? So you have some ideas of what's being produced, and so that other people who are going to be doing new models, perhaps not in your organization, um, have some place they can look to see that, oh, I don't need to build a model that does that. There's already one that exists, and I can get that. This again also could be done with a feature store, um, but perhaps with a small number of models, the feature store is kind of overkill. Monitoring and then you kind of monitor the results. You look at um, systemic data validation and systemic surveillance. You take a look at everything that's going in. Um, Most of the MLOps frameworks, the KFPs, the TFXs of the world, have some sort of systemic data validation tools that you can build from the beginning. If they don't, and you're building your model on your own, you can use things like Great Expectations and other things like that to get systematic data validation in place. Um, Probably the same with surveillance. You probably could use those same tools for model surveillance, depending on how you configure them, or you wind up writing your own custom metrics for surveillance and your custom reporting. Um, that's kind of the critical part. When we talk about some of these things, especially around standardization, that tends to be a very sensitive topic, because nobody likes being told what to do. And a lot of people go into software engineering and machine learning, because they're essentially creative people, and they want to be creating new things. And having somebody tell you no, you can't do that, chafes sometimes. And so it's important to understand when you're developing standards to get buy-in from people as you're developing it. It makes it a lot make adoption a lot easier. And then at the same time, understand that a standard should change over time. You don't set it in 1990 and then never change it. You should reevaluate your standards every 18 months, probably at the outside, and make sure they're still relevant to the current, to the current technical market. Same thing with your framework. Is this still relevant? Your chosen, framework. And so, maybe you don't change it every 18 months, but maybe you look at this and go, okay, well, TFX is no longer being maintained, for example. We need to have a plan to migrate from this MLOps framework that is no longer maintained or relevant to something that is more relevant. How do we do this? How do we either sunset old models? Do we migrate old models, or do we just leave them be because they're fine and just put them in containment and then move on to this next framework? And then from those standards, you just start develop. This is where you're starting to get your acceleration and velocity, because you can start building templates. You can start building components that are used, your common components that are used in your organization but are unique to your organization. You can start building those and reusing them. But without some form of standardization, it's very difficult. The best level of reuse you're going to get is cut and paste reuse. And that's not really great, from an architectural and system engineering perspective, because that just makes a lot of places you have to fix when you cut and paste that bug um, around. And as everybody on this call probably has had that experience. Um, and you know, kind of move that way when you're doing your standardization. Sort of um, start do kind of like the blood pressure cuff approach, is you start fairly loose, and then as time goes on, it just gets tighter and tighter and tighter, um, around your standards. And then a lot of times it becomes a lot easier. People don't have as much beef with it, especially when they know you're going to take reasonable requests and update the standard based on reality. Um, but anyways, that is basically the talk that I have. I'm out of time. I only had about 45 minutes. So um, that's it. And if there's any questions, I guess Ben will ask me.
Awesome. Thanks so much, Stephen, for coming on and talking. I don't think that we have any questions from the audience yet, but while maybe they think and linger, I'll ask a couple of my own. What would you say? You've done obviously a lot of really large projects. What has the scale of those been from your experience in terms of like teams? What's the smallest you've worked on, and what's the largest that you've worked with?
Well, from team's perspective, the smallest project has been the ones where I'm the only person working on it, and I'm working on it part-time, right? That's about the
Got it.
smallest you can really get and have a project. The largest team project I've worked on had about 30 people on it. Most of the team projects I've worked on over time wind up being around 7 to 8 people, um, on directly on the project. And then, you obviously have the other teams that are doing support or building ancillary things for the projects, for instance, the website, or and so I don't generally include them in the MLOps part of the project. The actual project itself may have 100 people on it. But the MLOps part of the project, where that's kind of interest here, is really it's 7 or 8 people, because that's about the biggest you can really get a team and have it still be functional given the communication overhead. I think anything more than 7 or 8 people should probably be split into 2 teams, who are then coordinating on various parts of the pipelines. And I've seen that done,
Got it.
or done that myself. It's pretty reasonable to keep it that size.
And when you are, we actually have some questions. So here's one question that just came in. When do you know, similar to the question I was just going to ask, actually, when in your experience have you found that it is time to create a data catalog or a feature store or something of that nature?
The beginning.
Okay.
If you've got something that's going to go to production from this, it's no longer an experiment. It's going to be a job. You need to get it in the data catalog. You can get away without one if you've got 1 or 2 projects, but you've got a document. You have a data catalog if you've got 1 or 2 projects, but you have documented output. Like, this is what the output format is, and this is what it looks like. You have a data catalog. You just don't have a unified data catalog. And so each project should always have that. You should always know what your outputs are, what your inputs are anyways, and should always have that written down. How else are you going to know if you're impacted when somebody changes a downstream or upstream, source?
That makes sense.
But
have you found any tools? Have you found any tools personally that have been great? I know there's a million out there. Are there any that you tend to go to for data cataloging?
I don't like any of them. I've been using Calibra. I've been using, it's okay. I honestly think this is one of those areas where data catalogs are so generic and their uses are so varied that it's hard to build a tool. Because, think of data catalog, the first place I think of, data cataloging tools is I go look at data lake tools, not MLOps tools. Because data cataloging is critical to making a data lake or data marsh useful. So I tend to look over there. I haven't found any that I'm terribly enamored with, but many of them, I've been using Calibra. It does the job to a degree that is acceptable. But I think that's the other thing too, is the difference between, say, somebody who's responsible for delivery versus somebody who is experimenting, is that I don't really have the time to look for perfect. I have the time to look for good enough. And I have the time to look for good enough and then move forward going, we may have to change this in 2 years, but we might do it anyways. So, I have the time. I look for good enough.
Yeah, that's a great idea. The perfect being the enemy of the good is always a great mantra to go by, not just for ML, but honestly anything but software included. We actually have a question from Demetrius. What are some of the classic obstacles that present themselves in ML that don't present themselves in classical or traditional software engineering?
The biggest one is, how do you train it? How do you segregate data? How do you train it? How do you promote training to production? Because training is a production process, but it's often not seen as a production process. And so sometimes you build your training and then it's hard to get those weights into production because now you don't have a life cycle for it. Validating is the other part, where you're actually trying, the assumption from most standard software things is that you've tested it, you put it in production, it's going to work. Your validation may be 10 minutes. It's not something you do every day or every week or whatever. So validation and surveillance are parts where to a standard line of business app, surveillance is just monitoring, right? You're making sure it's not crashing, that the failure rate is within acceptable bounds, and that your response time is good enough. Where with a machine learning or statistical learning application, you're not looking at, that's not good enough. Does it run is not good enough. You have to look and go, well, am I predicting with the level of accuracy I need? Are my predictions, what is my training serving skew, right? This is not a thing in standard line of business apps, right? You don't look at your training data and your serving data and going, well, is my training data set even valid anymore? Which you need to track over time. So those are the kind of things where education about how that works becomes critical, especially if you have a team that manages the software development lifecycle that can prevent you from going to production because they don't necessarily understand all of the processes involved in your, in the MLOps world or in the analytics world, really. Um, that's part of the motivation for MLOps is having a unified. It's easy when you have a unified organization or a unified structure. It's easier to discuss with other people because now it's like, look, this is what we're doing. Here's written down, and this is how we're going to do it. And I've got executive backing to do this. It's a lot easier to talk with your DevOps teams and make progress because then they're looking like going, oh, this is not just some guy having an opinion, right? This is a process. Um, and having that documented, written down, and then moving it forward. So it's like, look, the life cycle is different. So I understand your concerns, SDLC monitor, but it's not fully, we're not fully, this is not marching along. This is not a copy. It's not a clone. It's a cousin. And, there are differences.
Cool. Yeah, that was a great answer. I think so. We're almost at time. If anybody has any other questions, otherwise I might let you go, Stephen, and give everybody just a few minutes back. But thank you so much for coming on. I really appreciate it. This was an incredible amount of knowledge, and it'll obviously be on YouTube, and we'll share it when people are ready to get there.
All right. Thank you very much.
Thanks.